everyone. I hope you all are good. So in this session, we are going to continue our number system, and this is going to be part 7, where we have been discussing important previous year questions of the topic number system. So let's start with the first question of the video. So first question says, if the number 42573 star is exactly divisible by 72, then what is the minimum value of star? Now, for divisibility rule of 72, we have, because it's a composite number, it is composed of different numbers, right? So we have to break it into such numbers of which we know the divisibility rule. So we know the divisibility rule of 9 as well as 8, right? What is the rule for 9? Sum of the digits should be divisible by 9. And what is the rule for 8? Last 3 digits of any number, if they are divisible by 8, that means the complete number is divisible by 8. So we are going to apply these two numeric values divisibility rules here, that is 9 and 8. So let's start. Divisible by 72, let's see. So we have a number, and that is of course this 42573 hash. Now this hash can take only a single value. That means first, if you check with the sum of the digits should be divisible by 9. Let's check the sum. 4, this is 7 and 2, 9. So wherever I'll get a multiple of 9, I'll cancel that. Then 5 plus 4, 9, cancel. Now 3 is left with something else. So what can I add with 3 so that it is divisible by 9? So this is, of course, I can add a single digit here. That means it can only be 6. That means the value of the star can be 6. Now let's check it for 8 now. So the same number, divisibility for 8, as we need to check the last 3 digits whether they are divisible by 8 or not. Now check it. The number is 42573 and star. Now what are the last 3 digits, guys? So these are the last 3 digits. Let's check this 73 hash. Let's check it divisible by 8. 8 nines is 72. 1 star. Can you tell me what can be the value of star if this star is divisible by 8? So you know this is this has to be 6, because we know that if this is 6, so this is 8 to the 16, and 16 remainder is 0. That means again the same value of star is coming, that is 6. So what is the answer of the question? That is 6. And this is the minimum value. Before this we can't give any value, because see here the sum was 9, right? So we have to make 9 or 18, but we can't make 18. Why? Because if we give value 15 here, it is not possible, because star is a single digit value. That means we can only give 6. Similarly here also, except 6, there is no such number which comes in table of 8, so this is again has to be 6. So the answer of the question is 6. Let's move on to the next question. Again, divisibility question. Which of the following numbers is divisible by 3, 7, 9 and 11? All right, now we must know the divisibility rule of all of these. For 3, what is the rule? The sum of the digits should be divisible by 3. For 7, there are different rules for different digits. We will discuss that. 9, again, the same rule. Sum of the digits, here it was to be divisible by 3. Here the sum has to be divisible by 9. For 11, we have discussed in the previous videos as well that it has to be, in the previous videos we have done like divisibility is sum of the digits at odd places minus sum of the digits at even places. That has to be 0 or a multiple of 11. This is what we have done in the previous sessions. Now let's move forward with so the best way is to check this question by options. Now let's start with the first. The first option says 639. Now check the sum. 6 plus 3, 9, 9 and 9, 18. This is divisible by both 3 as well as 9. This is fine. But if we check with the 7, now what is the rule for 7? See, for 7, if it is a 3-digit number, what we do, we take the first 2 digits and then the third. What we do, take the first 2 digits and subtract the double of the third. So that is going to be 63 minus 18, because the third number here is 9. If you double it, it will be 18. So this is going to be 13 minus 8, 5, and 5 minus 1, it is 4, 45. You can see this is 45 is not divisible by 7. So this number is not my answer. Why? Because this is divisible by 3, 9, but it is not divisible by 7. So there is no need to check for 11. Of course, this is not divisible by 11 as well. You can see that if you check it, 6, 3, 9, the sum of the digits at odd places is 15, and 15 minus 3, this is 12. 12 is not divisible by 11 also. So this is obviously not divisible by 11 also. So this is not the answer. Now check the second option, 2079. Just cancel wherever we have we are getting this sum as 9 or 3. So 3, 7 plus 2, 9, 9 and 9, 18. So this number is divisible by again 3 and 9. Check for 7. Now what is the rule for 7? We have a rule, and that is that if we have either better you check directly because there is a rule, but that is time consuming. So I prefer students that they will check this verbally also, or calculation wise, because the rule is like this: you have to take pairs of 3. So if you have taken pairs of 3 here also you have to make pairs of 3, right? So this is little complicated, so better we check directly by 7. So 7 2s are 14, right? 6, 7, and 7 9s are 63, and this is 49, and you see this 7 7s are 49. This is cancelled. Okay, and if you I need to tell you the rule. The rule is like 2079. So this is 207. Take the first and then subtract the second. That is 6. 17 minus 9, 8. This is 9. So this is 198. If you check 198, right? Yeah, there is some correction here. See, the rule is like take the first 3 pairs. So this is we start the pairs from the last. So 2079, and the last 3 is this, and single is, so subtract it. 79 minus 277. 077 is divisible by 7. So this number is also divisible by 7. So this is the rule. We need to take pairs of 3 3 in 7, and from the last we start, right? Not from the beginning. All right, so this is done by 7. Now check for 11 as well. Check for 11. So better the rule of 7 you can remember, and you can directly check also. Okay, next is 11. So this is 2079. For 11, what we need to check? We need to check this is sum of the digits at odd places and sum of the digits at even places. So this is 9. 2 plus 7 is 9, minus 9 plus 0 is 9, that is 0. Yes, this is 0 coming, so this number is also divisible by 11. So that is going to be my answer, because this is done already. There is no such option like 1 and 2, so there is no need to check further. So my answer is option B. And if you want to check, suppose, so you can check 3791, 7 plus 3 10, 10 plus 1 11 plus 9 20. This is not even divisible by 3, this 9, because this is 10 19 20. 20 is not divisible by neither 3 nor 9, so this is cancelled. Similarly, if we have, this is divisible by this 9, 7 and 1. So this is divisible by 3 but not by 9. You can see the 3 is left, so this is also not the answer. So what is the correct answer? The second option, right? All right, let's move to the next. Again, completely divisible by 88 we need to check, and the number is nearest to 9217. So we'll check directly the options, which number is closest to 9217. So you can see this option. So check it. Again, divisibility rule for 88 has to be 8 into 11, because 88 is a composite number. So we need to break it in 2 numbers, and those numbers rules must be very clear to us. So we know the divisibility rule for 8, last 3 digits, and 11 we have just discussed, sum of the digits at odd places, sum of the digits at even places, right? So this has to be 0 or multiple of 11. Now let's check this. So we have this number as say 9240. So if you check, 9 plus 4 is 13. Sum of the odd digits places, minus 2 plus 0, that is 2, and that is coming out to be 11. So this is done by 11. Fine. Let's check for 8. So what is for 8? We need to check the last 3 digits. So 240, obviously if you divide it by 8, it is cancelled 30 times. 8 3s are 24, right? So this is cancelled by both. So this must be the answer, because there is no such number which is closest, and this seems to be closest this, but this is the most closest. And for the further things, you can check the other options as well. Let's check. If you want to check this 8 and 11, so you see, for 11 this is 9 plus 5, 14. 14 minus 3, this is done by 11. But for 8, 152. Check the last 3 digits. 9, 8, 8 ones are 8, and this is 72, 8 9. This is also cancelled, but the problem is this is not near to 9217 as compared to this. So that's why out of these two, we'll check, we'll say this one. Similarly, 906 for also, if you check, 9 plus 6, 15, 15 minus 4, 11. This is done by 11. And for 8 also, this is done, but this is not more close. So out of these two, we'll again compare and get B. If you check this, 9 plus 8, 17. 17 minus, this is 17 minus 5. So this is not even by 11. So this is obviously cancelled. So what is the right answer? Option 3, right? All right. Next is the question for a kind of simplification. So we can directly do, because we know this number will come over here and this will go here. So I can write 4, 3. Even we can solve it mentally, but I just solve. If you are not able to solve it comfortably, 5, 6, 1, 8. So we just need to subtract it. So this is 3, 11 minus 8. Then 2 minus 1, 1. 7 minus 6, 1. 10 minus 5, 5. 9 minus 6, 3. So 2. 12 minus 5, 7. And 3 left. 3 minus 2, 1. So answer is going to be option 3. You can do it directly here. 11 minus 8, 3. Like that. 12 minus 2 minus 1, 1. Like that also we can solve. Next question. So now there is a number n, and it's a whole number. You know whole number? 0, 1, 2, 3, and so on up to n. These are all the list of whole numbers. So a whole number is divided by 4, gives 3 as a remainder. So suppose this is a whole number. I divide it by 4, and this is giving me 3 as the remainder. What will be the remainder if 2n has to be divided by 4? This is what we need to tell, that what is the remainder. Now if you check it, you can take some value also, or you can do it directly also. Suppose I take n is a whole numbers, and divided by 4 gives 3 as the remainder. So if I want to write this n, can I write? This is some question. So n has to be divisor into quotient plus remainder. I can write like this. So this is n value. Now this 2n has to be divided by 4. So what is 2n now? You can see double of this, 2 into 4q plus 3, right? And this needs to be divided by 4 again. So if I expand this a bit, you will get 8 times q. This is multiplied with the 2, and 2 3s are 6, and divisible by 4, right? Now you just divide it in both ways. So that means I can write it like 8q by 4 plus 6 by 4 remainder. So this number must be divisible by 4. You can see that 4 2s are 8. Whatever is the quotient, this number will always be divisible. What about this 6? If you divide 6 by 4, obviously the remainder is 2. So what is the answer of the question? The remainder is 2 here. The answer is 2. So this is one way to do this. If you want another way, you can take some value. Like if you take n, a whole number, as 7. Why? Because 7. Because if I take this q, like n divisible by 4, remainder is 3. I can take this qn. So this has to be 4 into 1 plus 3. That is how this is 7. The value of q I have taken 7, because if I take 7 here, this will be remainder is 3. So if this is doubled in the second case, as it is given, it is doubled 2n. So 2n is 14. Now 14 divided by 4, 4 3s are 12, remainder is 2. So this is more easy. Even you can take this q as 2, 1, 2, 3, whatever, your answer will always be same. Like if I take n as or q as 2, suppose. So if this q is 2, so 4 2s are 8 plus 3, 11. Now 11 double is 22. And if you divide 4 divided by 4, so remainder is again 2, right? So this is always same. You take any value of q, your answer will always be same, right? Here we have taken 1, you can take 2 also, you can take 3 also, but the simplest value you can take is 1, so go with that. All right, next question. So if you read this question, this is quite a little tricky. Why? Because some big values are there. So but we remember, this is, say this is a number a, this is b, and can I write a plus b whole square? Because again we have a and again we have b. So can I write a minus b? Again here a into b. So if you remember this shortcut formula directly, you can solve this question in few seconds. A plus b whole square minus a minus b whole square. This is what we have as the numerator. Now this is a into b. Now if I expand this, what I'll be getting? I'll be getting, if you expand it, if you must remember this, actually this is 4ab. So if you divide it by ab, your answer is 4, and that is fourth option. But if you don't remember, you can expand it in the exam also. Like this, a plus b whole square is a square plus 2ab plus b square. And if you expand it, minus a square plus b square minus 2ab. You know the difference, only 2ab sign changes, rest remains same, and that is ab. So if you subtract it, it is going to be a square plus 2ab plus b square minus a square minus b square plus 2ab. And if you divide it by ab, you see this is cancelled, this is cancelled. 2ab, this one, 2ab and 2ab, that is 4ab. So this is the formula we are talking about. Here ab is in denominator, so if you cancel it, obviously the answer is 4. So please remember this formula, that this part is always equal to 4ab, right? This part is always equal to 4ab, right? Quite useful, right? All right, next is, and you can remember one thing also in this. If this is subtraction in terms of if there is plus here, so what is the answer? So if you expand it, a plus b whole square, so a square plus b square. So in this case, it is twice of a square plus b square. Suppose there is a plus here, like what I want to say is a plus b whole square plus a minus b whole square. So if you expand it, it is going to be a square plus 2ab plus b square plus a square minus 2ab plus b square. So if you see here, 2ab is getting cancelled now, so whatever left, a square left is 2 times and b square also left is 2 times. So that is going to be twice of a square plus b square. So right, so you can remember this, if there is a plus here, answer is twice of a square plus b square. There is minus here, 4ab is the answer. All right, so on the basis of the same formula, we have another question. If you read, this number is suppose a, and this is also, and this is getting multiplied, so I can say this is a square. Similarly, this is b multiplied twice, and powers base same, powers gets added, so a square plus b square. Then 2ab, right? 2ab. So this is multiplication, so you know the formula, right? So what is the formula? A plus b whole square. Simple formula. Now we can write it like here a is 397, b is 104. So this is how much? 501 whole square, right? So now you apply the base method, or you can solve it again like this. 500 plus 1 square. What is again 500 square plus 1 square plus 2 into 500 into 1, and that is going to be 25,000 plus 1 plus 10 right? And this is 1000. So this is 25 four zeros plus 1001. So what is the answer? 25 and then 1001. So this is the answer. And if you don't want this, so remember, see my videos of Vedic maths where I have discussed the base method. There I have discussed that if you want to multiply 501 twice, so you take this as a base. Now what is extra? You take 1000 as the base. Suppose if you take 1000 as the base, and this is here the main base is 1000 and the temporary base is 500. So this is one more than the temporary base, and this is one more than the temporary base. So 1 1 is 1, and this is going to be 502. Now for base 1000, what we do, we keep 3 digits here. So if this is only 1 digit, so we take these 2 digits extra, right? And what we do, we half this, because this temporary base 500 is half of 1000. So if you divide it, you will get 251 and then 001. These three and the half of this has to be combined, right? This is one way. Or if you are not comfortable here in this way, you can solve. I've discussed the other way also. You don't take 1000 as the base, you take 500 as the base only. But remember the method, it is 1 into 1 is 1. Now 501 plus 1 is 502. Remember, we always multiply this left hand side with the base we take, and this sign it was plus, so it is going to be if you 2 zeros here, 5 2s are, this is 10, so this is 10. So 25100 0 plus 1, so that is again coming out to be 251001. So this is the answer of the question, right? So let's move ahead. All right, another simplification based question. So it's simple, just add these three, because as per the rule of board maths, we have this bracket, so we need to solve this bracket first, and then we need to solve this bracket first, and then after that we can subtract it, because board maths is bracket of division, multiplication, addition, subtraction. Of is also meaning as the same, but of as a word has to be mentioned, right? So this is the difference of multiplication and of. So if of as a word is present, we multiply before division, right? So this is the, and B for bracket, and we also V for these bars. If some bar is there, then we take this as the first priority. So here we have only brackets, so we'll solve brackets, and then we'll add, and then we'll subtract. So let's start. So we have the numbers, just add manually. 3 plus 4 7, 3 plus 4 7, 7 plus 0 7, so I'll write it here 7. 2 plus 6 8, 8 plus 2 10, 1 carried here, so 8 plus 1 9 plus 4 13, so carry now 1 again, so this is 2 plus 7 9, 9 plus 5 14, again 1 carry, and this is here, so this is 3 plus 1 4, 4 plus 4 8. You can solve like this. Now you need to multiply this 317 into 89. So let's multiply it, although I have told you the methods also. So this is like this, 89. So if you see my basic Vedic maths videos, I have explained this thoroughly. So what is the rule for 3 cross 2? The rule is like this: you apply 1, then 2, then 3, then 4. So these 4 brackets, these 4 arrows has to be used here. Let's start with the first. So this is 1 first. So 9 7s are 63. 6 is carried. Now this first is correct, done. Now apply the cross through the first 2 onto the left side. So this is onto the right side, sorry. So these 2, 9 1s are 9 and 7 8s are 56. So 56 and 9, that is 65 plus 6, 71. I hope you are getting my point. See, first we have done this, 9 7 is 63, 6 carry written here, 9 1s are 9, 7 8 is 56. First we multiply and then we add. So 56 plus 9, and that is 65 plus 6 71. So I'll write here 1. Now 7 is carried to the next, so I write 7 here. Now this is also done. Now focus on the next, that is this one. So how do we apply this? We apply this like this. So now we'll just shift this from this side to this side. So this is going to be like this, 1 and 2. So now apply. 9 3s are 27 and 8 1s are 8. So this is 35. 7 was also carried. So 35 plus 7, 42. That means I need to write 2 here and 4 carried. Now this is also done. Last is this one. So just like this, 8 into 3, 24. 24 plus 4, 28. So this is the answer of this. So you just subtract the answer of this bracket. So this is 2 8 2 1 3. Now just subtract it. 7 minus 3 4. This is 10 minus 1 9. This is 2 minus 2 0. This is 14 minus 8 6. 7 minus 2 5. So answer is going to be 56094, which is the fourth option. I hope this is clear. Okay, let's move to the next. This rule we have already discussed and used in the previous video. If you see, xn minus an is completely divisible by x minus a. When it is, so this can be for any natural number. Let's understand. If you take n as 1, let's suppose if you have taken n as 1, so what is the question? It is like x1 minus a1. Is it divisible by x minus a? Yes, because this is the numerator is the same number as the denominator. So yes, this is cancelable. So if you take n as 2 now, because there are two conditions, whether n can be odd or n can be even. So let's take now even. So x square minus a square. If you know a square minus b square, a plus b and a minus b. So this is divisible by, again, x minus a also, you see. So whether you take an odd, whether you take an even, this is cancelable because this is x minus a. Okay, so what is the answer? N can be any natural number. Even if you take x cube minus a cube, you know the formula, a cube minus b cube, a minus b, then a square minus ab plus b square. So if you can see this is also divisible by x minus a. So this is also correct. So this is valid for any natural number, right? All right, so last question of the video. Which of the following is completely divisible by 45? The same we have used before also. 45 is a composite number. Composite numbers are those numbers which are not prime. They are except prime, right? So this is can be broken as 9 into 5, right? So we know the divisibility rule for both. So what is the divisibility rule for 9? We have already discussed. Sum of digits should be divisible by 9. For 5, the last digit can be 0 or 5, right? Now let's check the options. First option have 0 5. So all numbers have 0 5. So all numbers are divisible by 5. So we need to check only by 9. So let's start with the first option. If you see the first option, 8 plus 1 9 cancelled. Here see, 5 plus 1 6. 6 plus 6 12. Now 12 plus 0, 12 is left. Out of 12 you can take 9, 3 is still left. That means this is not divisible by 9. Go ahead. 5 plus 4 9 cancel. 3 3 6 plus 2 8. It is not 9. So this is also not cancelable by 9. Of course all are divisible by 5. So we need to check only by 9. This is the question now. Check it. 6 plus 8, 14. 14 plus 2, 16 plus 2, 18. Yeah, this is divisible by 9. So this has to be the answer of the question. So what is the answer? Answer is third option. Even if you want to check, you can check 5 5 5 15 plus 3 18. Up to here 18 is cancelled by 9. Go ahead. 3 and 2 5. 5 is not cancelled by 9. So this is again not the answer. So guys, the answer of the question is option 3. Right. So I hope you enjoyed the video. You enjoyed the questions. So you can subscribe, like and share this channel with your friends. So thank you so much.